Welcome back. We are going over quiz 5. So I started off this quiz by giving you the 8 guidelines from chapter, was it 5B? So there's the 8 guidelines for evaluating statistical study. So I'm not really expecting you to memorize like all these 8 different guidelines, but you should be aware of what they are, right? To be honest, like I don't have these like memorized like by the wording that the book has. I do probably do these in my head when I look at a study, and these are all things that I do consider, but I don't necessarily have this thing memorized. But I could tell you what they mean by each one of these sorts of guidelines. Okay, so we will use these later a little bit, and they're mostly sort of that you have a multiple. It gives you more of a multiple choice scenario. It gives you what to sort of pick from, and it gives you the sort of wording that I'm probably going to be looking for, right? So here we see number 1, identify the type of sampling used in the following scenarios. So these we're either talking about simple random sampling, systematic sampling, convenient sampling, or stratified sampling. So you have basically 4 choices here. So if we read all these 4, the program coordinator for ACC Math collects the grade averages of 7 randomly chosen students from each of the 23 math courses available. B says you decide to ask your coworkers whether they think pineapple belongs on pizza. C says it's 3 a.m. and you decide to see who is awake and what their current mood is, for scientific purposes, of course. It'd be totally silly to have the entire neighborhood mad at you, so you decide to knock on every house whose address is divisible by 5, or saying like every 5th house is about probably the same thing. You set up a robocall program that surveys people over their frustration with automated systems. The program selects numbers at random from a database to call. Okay, so I'm basically giving you one of each here. So if we're looking at this, we have A, and I'd like to contrast that with like probably D, right? This says we have a robocall program and it's using a selecting numbers at random from a database. So this is selecting numbers at random. This, it doesn't really tell us how, oh, there it goes. 7 randomly chosen. This is also selected at random. But there's a key difference between these two. This one, we're grouping them by the course, right? And so we're doing 7 out of each of the 23 courses. And so this is the one where we have things grouped. And so this would be the stratified. And this would be the simple. So this is the stratified, and then finish it off, call it stratified sampling. And this would be the simple random sampling. Okay. So the other two, you decide to ask your coworkers about pineapple on pizza, or it's 3 a.m. and you're going to do every 5th house. So these two, I hope you see it right away. If you're going in your class, you're not going out of your way. So this is the one that's really easy. Sampling. And the other one, we're using a simple system every 5th house. So this is the systematic sampling. Okay. Okay, so they want us to explain the difference between an observational study and an experiment. So in an observational study, the main difference is that you're not doing anything, right? You're not actively doing anything in an observational study, whereas in an experiment, you're setting things up. And so the book says, what do they say? In an observational study, researchers observe or measure characteristics of the sample members, but do not attempt to influence or modify their characteristics. So they're not the key words there is they're not attempting to influence or modify the characteristics. The observational study is observed. That's basically all they're doing. In an experiment, researchers apply a treatment to some or all the sample members and observe the effects of the treatment. Grab red, and then I can just kind of juxtapose them. Okay. And so the key word there is that they apply a treatment. So this is where you're creating a setup. You're applying a treatment to some or all members. Or you can just like control variable scenario. And we talked a little bit about it. I don't think I put it on here, but it is something you should absolutely kind of know. This is where we actively set up a control variable scenario. If it kind of coincidentally happens in an observational study, we call those case studies. So sometimes your population naturally sort of divides itself into a control variable sort of scenario. With that said, I feel like usually experiments are a little bit more desirable. And part of that is like that confounding variable thing, right? If there's a third variable out there, we can try to do a control variable with another variable. We can do multiple variables and rule out things. Versus if you're just observing and reporting, you get the information that's given to you, right? You can't really do a whole lot beyond what is just happening naturally. So treatment and control group. So the treatment is the one that gets the treatment. The control is the one that doesn't get the treatment. Something along those lines, right? The treatment group in an experiment is the group of sample members who receive the treatment being tested. The control group in an experiment is the group of sample members who do not receive the treatment. And I know I'm writing a little bit of hyphenated and really sort of abbreviating things here. I'm writing notes in here. If you're submitting this for an assignment, I definitely want like write some full sentences. You're in college. I'm just kind of going over this and taking notes on it. Okay, so that is the treatment group, gets the treatment. Gets no treatment. Maybe they get a placebo. Who knows? Single blind versus double blind. So single blind, the person that the experiment is being done on doesn't know about the experiment, and double blind, neither the person doing the experiment nor the person that the experiment is being done on know whether they're in the control or treatment group. So I think they say participants for the person. So in single blind, the participant doesn't know if they are in the control or treatment group. And I'm just going to do a little ellipses there. I don't feel like finishing that sentence. Both the participant and the experimenter don't know whether the participant is in the control or treatment group. Okay. Despite all the recent scandals, a poll indicates 62% of the surveyed voters intend to vote for the incumbent Mayor McHorrible. He needs 45% of the vote to win without a runoff. The margin of error in the poll is 12%. Will McHorrible re-win his mayoral seat? So if we look at this, what does he have? 2%. And so this is that thing where you have to take 62%. We know the margin of error is 12, so we have to subtract 12. We have to add 12. So this gives us two numbers that we are bound between. So this is going to give me 50, I believe. So we're looking at 50 to 74. So he should be getting, and this is like a 95% confidence interval or something like that. He should be getting, with 95% confidence, somewhere between 50 to 74. And if that is true, will he win the election? Well, if he's getting between 50 to 74 and he needs 45, the lowest he's going to go is 50. I think he will win it without a runoff. But yes. I don't know if it should be happy with an exclamation mark for that guy. Seems pretty horrible. Okay, so this, should you believe the study, is the next thing that we're looking at. Based solely on the information given, do you have reason to question the results or methods used in the following hypothetical studies? Explain your reasoning. So this is the thing that you should go back to that first page and look at those 8 rules. Because there is one of them that each of these is really, really leading you towards one of them. And there is a certain one that I really want you to put on these. There are probably other things you could say and other things you could talk about that are also true, but there should be one of those 8 rules that these really lead you into. So this first one says, a study by Sweetums showed that their sugar splash soda reduces the risk of diabetes by 13%. Okay. So this is, if we go back, look at this first page. If we're looking at these, I think it's pretty obvious it's leading you towards like this one called considering the source. So they are talking about their own product. Not true. I don't think a sugar-coated soda is going to reduce diabetes. But it might help them sell their product. So let's look at the next one. Ooh, got a little coffee on the paper now. So a survey conducted among ACC students found that 13% found their math professor to be too nice, 24% found them to be too mean, 5% found him to be just right, and 58% had no response. Was probably the correct thing to do. Okay. So if we're looking at this thing, we're looking at these 8 different rules. The one that this really, really sort of falls into where's it at? I believe it's number 4, right? Defining or measuring the variables of interest. So if we're looking at these variables of interest, what does it mean to be right? Nice. Okay. And C says the Home Shopping Network conducted a survey to find out what was the most popular genre of music for Americans. They urged their watchers to mail a letter listing their top 3 favorite genres of music. So this one is almost, seems like it's from the textbook almost. So this one is going to be, they're looking for all Americans and they're only going to get their audience. So this is going to be the bias in the sample example. So this is a bias in the sample. And I really should ask you to elaborate if there is a bias in the sample about participation bias. These are both going to be present here. Only people that watch this and mail in a ballot. You're requiring people to mail something in. So you're only getting mail-in participation. You're selecting your audience, your home shopping network audience. And you're trying to make them represent all of Americans. So this is definitely a bias in the sample example. And it does say explain your reasoning. So maybe I should do a little bit more on this. Consider the source. They're selling their own product, right? It's the person selling the product. I explained it verbally, but I guess I'll go ahead and put it in writing for you. This one, if we talk about the survey, the defining variables of interest, what does it mean to be too nice, too mean, or just right? These are not well-defined variables, right? These have different meanings for people. Different strokes for different folks. Okay, so this is, what was I saying? And it's the things that have underlined, right? These are not well defined. If I ask you what does it mean to be too nice, it's not going to be the same thing across all different people. This one, the bias in the example, if you explain the biases, well, we're only going to get people to get mail-in. That's what I want. So I did say explain it. So if there is something with biases, you should definitely put down participation, put down why it's participation. Only people that want to participate by mailing in, getting a stamp, and putting that letter in a mailbox, right? That's requiring 2 or 3 different things. And it's like, ooh, each one is a degree of separation from getting more people in your survey. The selection is you're only getting the home shopping network audience. They're only getting their audience and trying to make them represent all Americans is not probably a good strategy. We got 2 more examples that are going to use this. And so if I look here, survey conducted contains the questions, do you support the abolition of basic human rights? So up until this, if I were to ask you like this question, it really sounds like I'm going to say yes to this question. Do you support the abolition? Absolutely. Oh, wait, what? No. So this is one of those, like it's a misleading sort of wording sort of thing happening here. So you have to be really careful with how you word things. Consider the setting and wording in surveys. And this is like a really sort of positive leading question. Hopefully something that you wouldn't want to answer positively to. Okay. And now this one says a study conducted measured the concentration of limestone in the tap water for Kyle, Texas and Houston, Texas. It found that there were higher concentrations of limestone in the Kyle tap water. The study compared this finding to medical records that indicate a higher prevalence of respiratory illness in Houston and concluded that limestone may prevent respiratory illness. So what is this saying? There's more limestone in the water in Kyle than there is in Houston. There's more lung problems in Houston than there are in Kyle. Therefore, it's the limestone that's preventing it. So this is, they're looking at one variable. And so this one, I'm trying to lead you into the beware of confounding variables, number 5. And why is that? Because there's something that probably is a better third sort of example. There's a third variable that we can think of. That would probably be a better variable to look at, and that's called air quality. If we look at air quality, it's probably better in Kyle than it is in Houston, and that's probably going to attribute to more or less problems with your lungs or respiratory system, right? So this is where they're narrowing their focus. Respiratory illness, right? And they're only looking at one variable. So this is the one where we want to be aware that there are other variables. If we're just looking at one, we have a really sort of narrow view of what's happening. And so there are other confounding variables out there. Third being probably the air quality, right? Okay. So now we have a list of scores. We want to make a frequency table, and they want to know if this is qualitative or quantitative. So I fixed my bins, so now my bins are fixed. Ooh. Are they? No. Ooh, I didn't fix this since I've printed it out. Hold on. All right, take two. Here we go. Now my bins are fixed. I have all these numbers up here. And the first thing they ask, is this qualitative or quantitative? Hope you know if they're giving you numbers and it's a measure. Okay. So we want to do the frequency of 95 to 99. I want to start out with the totals. That's probably the better thing to do, just so we're all on the same page. My totals here, if I'm talking about the frequency, and it's a class of 3 students, right here. If I want my relative frequency, it should be 100, and my cumulative frequency should be 33, and this one right above it should also be 33. So it should repeat. It should get up to 33 out there if we do everything correctly. Okay, but it's a good check. I sometimes like to start at the bottom. If I go 50 to 54 and count up, sometimes it's easier for me to do that. So if I look at anything between 50 and 54, and this is a random number generator, so I have no idea what it's spit out. Let's double check. Looks like I got 3. And now I'm going from 55 to 59. So anything else with the 50 in it? Okay, so how many is that? 1. Let me double check. Okay, that's it. 1, 2, 3, 4, 5, 6. 1, 2. Okay. 60 to 64. That's 65. We may not have any in. Ooh, there's one. Double check. Yeah, looks like one. 65 to 69. Looks like I got one. I think that might be it. 4 of them. If you know the concept, I think that's definitely probably the hardest part. Trying to see which one falls in which bin, right? It's easy to miss one. $70 to 74 now. There's 74, 75 is above, 74, 73. There we go. So that is 1, 2, 3, 4, 5, 6 of them. 6. Maybe a different color might help. 75 to 79. Making sure everything's got a cross through it, and I did already cross. Okay, so that's 3 of them. $80 to 84. $85 to 89. Do we got anything in there? Oh, too many left. I got one. Now 90 to 94. Looks like 92. I'll see if I counted these right. So this is where you should definitely be checking your solution. 3 plus 1 plus 1 plus 4 plus 3 plus 7 plus 4 plus 1 plus 6 plus 3. That gives me 33. Woo! All right. So we have our bins, we have our scores. Now we want to talk about relative frequency. So this would be 33. And I want to convert this to a percentage. This is about 9.09%. So I'll probably round things to 2 decimal places with a percentage. 1 out of 33. I'm going to do 4 out of 33. This is giving me 3 out of 33 again. This is giving me 9.09%. 7 out of 33. It's giving me 21.21%. 4 out of 33. 12. 6 out of 33. I don't think we did that one yet. 18.18% somewhere. Now I want to check these. And I did a bit of a rounding, so it might come to like 99.9%. It might come out to 101%, but it should be pretty close to 100%. So let's see. Probably a little bit under is what I'm guessing, because I think we rounded down for most of these. $9.09. Here we go. I'm getting 99.09. 99.99, sorry. So that's giving me 100%. It's just a rounding issue. I want to do cumulative frequency. So 3. One more, excuse me. 5 plus 4. The next one. 19. And then I add 3 to get to the last one. It's checking out. Okay, so we want to create a histogram for the score and frequency. So this is a thing, you could probably do it either way. Typically histograms, I think we typically do them on the x-axis. That's the way I typically do things, so that's the way I'm going to do things. I feel like the next problem might actually be a little bit easier, I think. Okay. So my frequency. How do I need to go? I don't even know. I need to go up to 7. So I think I'm going to go every 2 of them. So if I start up here, I'm going to go up 2. This is 1. Go up 2. So this is my frequency. This is my grade down here. So I'm not going to just start out at 0. So I'm really doing like a sort of break here. When I want to start out with a 70, I think I'm going to skip 1 and go to 75. Skip 1 and go to 80. Skip 1 and go to 85. Go to 90. 95. And my last one over here is ooh, no, I did not start out the right number. Sorry, I'm starting out at 50. Let's correct these numbers. 55, 60. This would be 65, 70, 75, 80, 85, 90, 95, and 100 on the end. Got just enough space. Okay. I know we did a previous example where they started out at 70, so I had that example in my brain. It's probably what I was doing. So between 50 and 54, I'm getting 3 hits. I want to go 1, 2, 3. Bada bing, bada boom. There we go. Between 50 and 54, I get 3. Between 55 and 60, I'm going to get 6. Between 60 and 65, it goes to 1.
65 to 69, I'm getting 4. $70 to 74, I'm getting that 7. $75 to 80, I'm getting 3. Right here. Ooh, just a little too high. There we go. And 80 to 85, I'm getting 80 to 84, sorry, I'm getting 4. $85 to 90, I'm doing 1. I'm doing 1, and I'm getting 3. Right there.
So this is the grade or the score. This is the frequency. This is a histogram comparing your grade to the frequency. Okay, so this is probably not the best test. There's like some people, there's a big occurrence here, big occurrence here, and it's kind of all over the place. It's probably not the best test apparently, but there you go. Probably need to rewrite their test. That's what that's telling me. But that's a possible outcome. All right. Here we go again.
But now we're getting the letter grades. 18 students. So if they give me a letter grade, it's not a number. This is just a qualitative. And if they're giving me 18 students, I know this is 18. I know this is 100%. And I know this is 18. And this would also be 18 right above it.
Now I want to count my A's.
I have 1, 2, 3 A's, my B's. I have 1, 2, 3, 4 D's. I got 1, 2, 3, 4, 5, 6 C's. I have 1, 2 D's. And 1, 2 F's. And if I count them, this is 10, 13, 14, 15, 16, 17. Where am I missing one? Missing a C. Double check. 1, 2, 3, 4, 5, 6. There are definitely 7 C's. Okay. 14, 16, 18. Should count up. Now we want to do relative frequency. So now it is the frequency out of the total. So if I do 3 out of 18. 16.67%. Okay. If I do 4 out of 18. 0.22%. If I do 7 out of 18, it gives me 38.89%. And the last one, 2 out of 18 gives me 11%. So now I want to add these things, 16.67. I want to add 22.22. I want to add 38.89 and 11.11 twice. This one does give me a perfect 100%. I think that's because I rounded some of them up and some of them down. It ended up balancing it out. All right, so now we're looking at cumulative. We're starting up with 3. We add 4 more, we get to 7. We add 7 more, we get to 14. We add 2 more, we get to 16. If we add 2 more, we would get to that 18. So we did that correctly. Now they want us to do a pie chart. Okay. So if I'm doing a pie chart, I want to look at my relative frequencies. I want to look in here. Let me get maybe like a pencil. And so I'm thinking like if I'm 50%, that would be perfectly in half. So this would be 50%. If I do a third, it looks more like something like that. And so I have this thing that is almost 40%. So if I'm thinking this is think about doing thirds, you think about like that peace sign looking thing, right? You think about doing 50%, you think about half the circle. So this is about 40%. So if you draw something, and again, then the important sort of indicator is that 25% is a 90-degree angle, right? And so this is the sort of thing I'm going to look at. Are you doing it obtuse, or are you doing it acute, or are you doing it pretty close? So I think we have some 22%. Those will be pretty close. They'll be a little bit shy of a right angle. So I'm definitely not expecting these things to be sort of perfect, but they should be pretty close. I want to go. Is it going to work? I want to go somewhere in the middle of those two things. So I'm going to do that probably. And this one is the C. 38.9%. I'm going to start with that largest one. And I think I'm going to work my way down, and I think I can go C, B, A, and do my F and D. And it will go sort of in order if I do that. The next thing is this one. So B is 22%. Right angle would be 25%. So it's a little bit shy of a right angle. So I'm going to do that. And hopefully this is the center, pretty close to the center of my circle. This is my B. My A is 16 and the remaining two are 11. So I'm just going to kind of guesstimate, if I'm being honest, about 16, and maybe these two have to be equal at 11. I missed my 11.11. Try to squeeze it in there. All right, so that's my pie chart. My pie. Those aren't the prettiest numbers, but I think they're doable. The next one is this stack chart. What do they call them? Stack charts or stack graphs? I can't remember. Stack plot, that's what they're called. Plot graph chart. We're looking at this stack plot, shows the number of staff over the course of a week for a restaurant called Easiest Pie. So we have greeters in blue, we have waiters, and we have cooks. How many greeters, waiters, and cooks were there working on Thursday? So this is making sure you know how to read this thing. So we're looking at greeters, we're looking at the blue. It looks like it's between 2 and 4. I believe there's 3 greeters. I believe there are
1, 2, 3. Gap here accounts for one more, but there's 1, 2, maybe 4 waiters. There should be. Gap accounts for 1, this accounts for 2, 3. So if we're looking at here, there should be 10 people total on a Thursday, which is exactly what it looks like. What sort of conclusions might one be able to draw about the trends in the number of greeters, waiters, and cooks, as well as the overall staff size? Okay, so if we're looking at greeters, it looks like they usually have a consistent amount of 2 greeters. It goes up to 3 and goes up to 4 on Friday and Saturday. So one of the things you want to tell me is something about how this weekend is busy, right? They're building up for the weekend. Most days they have the same amount of staff. I think they had an extra cook on Monday, maybe, right? It looks like their staff size is pretty consistent throughout the week, and it builds up to the weekend when they're busy. So there's a few different things you can tell me, but this is basically what this graph is telling me. They're mostly consistent through the week. It starts building up Thursday, it booms on the weekend of Friday and Saturday, and they have slow Sundays as well, right? It goes back down on Sunday. You could tell me about the greeters, so I should probably go into more details, but for the most part, we have about the same amount of greeters, and they slowly build up until up into Friday and Saturday. Same thing with waiters. There was maybe an extra cook on Monday for some reason. Maybe they had to come in and prepare things for the week. So there might be a story there as well. Who knows? But these are all things that you could tell me that would signify that you understand what is happening in this graph. So these are all things I could also ask. Do you notice anything weird about the cooks? I could ask something about that, right? And you should be able to tell me, hey, look, they started with 1. For some reason, they got 2 on Monday. If you're running this business, you're going to want to know why you have 2 cooks there, right? That's the sort of information that I want you to get at from this graph. All right. Percent change graph. Profit for Melange Mining. The following represents the profits for a small business named Melange Mining. You got to get that spice. So this one shows the date and the profit. This one shows the profit and the percent change. So when did they make the most profit? The easy graph to look at for that is this one. And we look down here at the date, 1/11/29. 2019. Sorry, is that what I said? 1/11/2019. When did it sorry, whew. Wrong graph. Not reading the question right at all. Sorry. When did they make the most profit, or when did the profit increase the most? Sorry. This should be when it increased the most. Totally off there. Not paying attention to what the wording says at all. So definitely pay attention to what your wording says. Don't do what I just did. Do as I say, not as I do. So If we want to know when they made the most profit, it would be the highest one right here, which is 1/4/2019. If we want to know when it increased the most, that would be the percent change. When did the profit from Melange mining decrease the most? Now we want to know the lowest percent change. And so that's the negative percent. That indicates it's decreasing the most. And so that was 1/9/2019. And when did they make the least profit would be the lowest bar here, 1/10/2019. Okay, so that is the final problem. I will see y'all soon. Get ready for the test. Don't forget your project that is due. All right.